Alright guys, so this is an interesting problem which is two sum. This is the first problem of Leetcode. And the problem statement is we are given an array and which has unsorted numbers essentially, and we also will be given a target number. So we need to find a couple of numbers in the array which adds to the target. So whose sum will be exactly equal to the target. So how can we do this? There are a few constraints of this problem. Number one is there should be no repetition in the answer you give. Like you can make, like if the target is 6, you can make, and you have an element called 3 inside the array, you can give 0, 0 as the answer. So that's the first constraint. And the next constraint is the given array is unsorted. It might be sorted, but it's not guaranteed. You can't rely on that. The next constraint is the array can have multiple solutions, but you need to return any one of them, which is good for us. Easy, isn't it? Okay, so how to solve this problem? If you think of an intuitive brute force way, we can just take 11 here. We can just write 2 for loops, pick the first number, which is 11, and go through all the numbers and check if it adds to 9. So this is a brute force method. Yeah, you can. Oh, okay, that's it. So if you take 11, you need to go to 2 and you need to add. You need to see if it makes 9. No, it doesn't make. 11 plus 15, does it make? No. 11 plus 7, does it make? No. And next, my first pointer goes to 2, which is now 2, and it will check 2 plus 11, does it make 9? No. And now 2 plus 15, does it make? No. 2 plus 7, yeah, it makes. So I return immediately the first pointer and the second pointer indices, which is 1 and 3, and that gives the answer. Cool, we got an answer now. But the time complexity of this is O of n squared, because we are taking one element and sweeping n times, and we are taking in one pass, we're doing n. In one pass, it is O of n. So we're taking one element and sweeping n times. And in the same way, we are picking all the n elements and sweeping n times each. So it becomes O of n into n, that is O of n squared. So, okay, there are O of n squared solutions, but the question is, can we do better? If we have to do better, we have some options. O of log n, O of n, O of 1. So I recommend you guys to take a pause now and think, what is a better solution for this? Fine. Okay, hope you guys gave a thought about it, and let me actually reveal the better solution, optimized solution. The optimized solution doesn't fall in O of log n and log n of O of 1. It falls in O of n. So O of n means you are doing one sweep to the array. So, and by the time you reach the end of the array, you find the answer. How can we do this? Okay, let's wipe this off. So we have to do it one sweep. So we'll take a hash map. Here we have the k, and we have the value. So in the hash map, we take 11. As promised, we are just sweeping once. We take 11 and we will subtract the 11 from 9. So it's gonna be 9 minus 11 goes into the key, which is minus 2. And the value will be exactly the index of what we will take, which is which is 1. All right, and before we insert this in the hash map, we check if there is this element, if there is some key with 11. Okay, so there isn't any 11 in the hash map, so we don't need to return the answer. That means we don't have a couple for this, and we need to insert this. Okay, and next we go to 2 and we check if 2 is present here. No, it's not present. 2 is gonna come, and 9 minus 2, which is 7. And the index is, I'm sorry, the index here is 0. And the index here is 1. And now 15. 15 comes, and it asks if there is a 15 here. No, there isn't a 15, so I just do 9 minus 15, which is minus 6. And I put it to, now 7 comes in. 7 comes in, 9 minus 7. It checks first 7. Wait, I will first check if I have a 7 here. Yeah, I have a 7. So that means we have a match. We have a couple for 7. So we take the 7 and the value of the 7, we construct an array here. We do 1, and this 7, we ask what is the index of this, which is 3. And we just return this. Alright guys, so that is the algorithm. This is the most optimized algorithm for this, which performs O of n in the worst case, which is, this is the worst case. We sweep till the last of the array. So, and yeah, the time complexity might differ based on the hashing algorithm, which the programming language supports. Fairly small arrays take off 1 for searching, so you need not worry much about it. So in a very complicated big array situation, you might end up in O of n square again, but that is, for this small problems, I think it's O of n. Anyway, that is the algorithm. So let's so if you're just interested about algorithm, you can just skip the next part of the video, which is coding of this. Okay, so let's do the coding real quick for this. Okay, so I'm doing the coding in Java. So first, I will declare an array. So in the programming interviews, which is done on whiteboards traditionally, they won't expect you to write 100% correct code, but correct, I mean syntax. I'm saying about syntax, not about the algorithm. They expect perfection in the algorithm though, but syntax, you might take a chance of 1 or 2 mistakes, but not more than that though. So let's do the coding now. First, we want a couple array, like array with 2 elements, which is the output. So we put the output, which should be an array map, array list, I'm sorry. And it should be an integer. Oh wait, we can just have an array instead of array list actually. Int of output is equal to new int of 2. Okay, very good. This is the first line. And the next line, we declare an hash map, which is I'm doing it real quick because wait, syntax. So I need to write integer here, but I'm still writing a shorthand notation just to save some space. Don't do this in the interview if you know the correct thing. go and you write a for loop. I less than or equal to nums dot size I plus plus. So you do one sweep in this for loop, and then you check the first for loop. So first element is if that element is present, if map dot contains key, k of nums of I, then you got it. That means you just need to return output of 0 is equal to map dot get of nums of I, and output of 1 is equal to map dot get. Oh, I'm sorry, there's no map now. It's just the I. Okay. And that's it for the fifth loop. Else, you need to end return this output. You just need not write else, because if you get the answer, you'll be returned. You don't reach the next code block. So, in that case, the next thing is, if I don't have it inside the array, then I need to insert this in the hash map, the element which I'm getting now. So, map dot put of nums of target minus nums of I, comma, the value will be just the I, and there you go. And at last, and you end the for loop here, and at last you return the result. That's very simple, so hope you get it. Thank you so much.